In this video, I will show you how to complete part 3 of the Jamovi project. So here we're going to be dealing with two sample tests. So we've got two populations. We take one sample from each population, or we take two samples from the same population. So if we take two samples from separate populations, they will be independent of each other, usually. And that's the first type of test that we're going to look at, is an independent two-sample test. We're also going to generate confidence intervals. So you're going to work from the file 241S97. That's in Files, Jamovi project files inside Canvas. And you're going to do an equal variance test and also an unequal variance test. And you're going to put in here your test statistic, degrees of freedom, your p-value, and your confidence interval. And then your sample means over here. So let me show you how to do that. So here we have some data. We've got two blood pressure readings, and then we've got a grouping variable. We just group these as group 1 or group 2. So one would be a placebo group and the other would be a treatment group. And what we want to do here is click on Analysis and then T-Tests, and then go to Independent Samples T-Test. You're going to take your two blood pressure readings and move them over. And then you're going to take your group and move that to the grouping variable. Now for the actual project, using gender as a grouping variable. So, and we could do this analysis just with one blood pressure reading. You're going to be working with exam scores for different exams. So these are not the two separate groups, BP1 and BP2. Those are just two different variables. So the two different groups are group 1 and group 2. So you want to click on students, that's equal variance, and then also Welch's, that's unequal variance. We are going to click on mean difference and then also confidence interval, 95%. So I'm going to right click and get rid of this output here. So there's what our output looks like. So we've got our test statistic, degrees of freedom, our p-value. The mean difference is the difference between the means of group 1 and group 2. And then we've got our lower and upper confidence limits. So that is what you're going to put in your table here. You're going to do that for 3 sets of data, exam 1, exam 2, and exam 3 for that course. And then your sample means there, if you go back to our t-test here and just click on descriptives, then that will also display your sample means for the groups. So group 1, 92.9, group 2, 92.6. Then you're going to come back and you are going to look at your sample statistics and you're going to decide which format do you feel should be used, equal variances for population or unequal. So you are going to make that decision here by looking at your standard deviations. So for example, here we can see between group 1 and group 2, we've got standard deviation of 5.2, 6.1. Those are fairly close. For the second set of data, 12.9 and 10.98. So this is basically 11 and 13. So in this case, you might think unequal variances because those are actually 2 units apart. Here they're less than 1 unit apart. So that's how you're going to make that decision. And then we're also going to look at paired tests. So paired tests is when you have some natural link between your two groups. So for example, some researchers will collect data on sets of twins, or for example, mother and daughter heights to see if there's a relation there. So there's a natural connection between the two groups. The mother and the daughter go together for each pair. So you're looking at pairs of data instead of two groups. So in this case, you're going to use t-test paired sample t-test. Now you're going to be looking at mileage for vehicles, miles per gallon with and without. And you're going to put that data in here. So you're going to have a mean difference, a test statistic, degrees of freedom, p-value, and then your sample means that will be from descriptives. And then your 95% confidence interval, you're going to do with minus without, and that matters how you add the variables. So let's look at an example here. So I've got blood pressure data again. So I've got pre and post, and then 1 is the first individual. So their pre-reading was 100, their post-treatment reading was 96. For individual 2, their pre-reading was 94, their post was 91, and so on. So each pair of measurements goes with the same individual. So that's a dependent test because the two samples are related to each other, whereas independent samples, they're not related. So in this one, you are going to click on your Analysis tab and then t-tests again, and you're going to go to Paired Samples. And then usually we would look at post minus pre for a repeated. So you're going to click on the post and bring it over, and then the pre and bring it over. So and this will be post minus pre. So you are doing with minus without. So you'll bring with over first and then without. And then you can see your test statistic here, degrees of freedom and p-value. If you click on mean difference, then it'll specify your mean difference, confidence interval. So here's your confidence interval. So that's what you'll enter in the lower part, and then click on descriptives, and we can look at the two means here as well as the mean difference. So I think you're reporting the mean difference, which will be right there. Yes, mean difference, your test statistic, degrees of freedom, p-value, and then your sample means will come from this data down here. Again, I'm using different data than you. We can see for my data, p-value is highly significant. So there's definitely a significant difference, and then this mean difference is negative. So that's saying post minus pre is negative. So that means that the post values are smaller than the pre values. So if this is a blood pressure medication, it's pushing blood pressure down, which is what we had hoped for. And then to finish up the project here, to test hypothesized differences other than 0, you have to compute your test statistic by hand. So when you do this paired samples test, your mean difference, you're just testing, is that greater than 0 or less than 0? If you want to test, is it greater than 1 or less than 1, then you have to do things by hand. So that's what they want you to do in the last step of the project. So that should take you through project 3.